All right, geometry, lesson 47. First one that we'll look at today, we're going to talk about circles and inscribed angles. Inscribed angles as opposed to central angles. What do we remember about central angles? Where's that vertex at? The center of the circle. Very good. All right, it was a simple question, expected a simple answer. Thank you for that. All right, now, does anybody remember the relationship between a central angle and its intercepted arc? If I knew what the central angle was, no, you're thinking of centroids in a triangle. This is angles that come from the center of a circle. All right, if I've got an angle that originates at the center of the circle and it comes out to the arc of that circle, what's the relationship of the angle of the central angle to the degree of the intercepted arc? They're the same. Very good. All right, so if you can remember that, right, you should know that it's not going to be the same with an inscribed angle. Okay, so don't get central angles and inscribed angles confused. But the relationship is not complicated. In lessons 23 and 26, we introduce circles. This lesson addresses circles, introduces inscribed angles of circles. We recalled that a central angle is an angle with the center of a circle as its vertex. And a central angle and its intercepted arc have the same degree. Another kind of angle formed in circles is what we call inscribed angles. It's an angle whose vertex is on the circle, not in the center, but on the circle, whose sides contain chords of the circle. We see this in this diagram down here. Okay, so we see the difference between an inscribed angle and a central angle. Yes? Hopefully it's very clear. All right. The arc formed by an inscribed angle is still an intercepted arc of that angle. In this diagram, arc AC, which is what we see, this would be the arc AC, is the intercepted arc of angle ABC. Okay, and we see angle ABC show up there with my red lines. Does this make sense so far? We understand what an inscribed angle is. Do we understand what an intercepted arc is? Okay. All right, if we can start off with that basic understanding, the rest of this is really not too bad. Where's my cursor at? It seems to have disappeared. All right, there we go. Okay, so with theorem 47-1, the measure of an inscribed angle is half the measure of the intercepted arc. So if I look at arc PQ, this, let's use a different color. This is arc PQ. Whatever that degree is going to be double whatever this angle degree is. So if angle PRQ is, let's say, 20 degrees, okay, then that means arc PQ is 40 degrees. All right, let's keep going. Let's just make sure everybody understands this. I'll go around the room. Katie, if my x degrees here was 30 degrees, what is PQ in degrees? No. Okay, it's not a central angle, so they're not the same. All right, if this is 30, then what is this? 60. Good. Okay, so we understand that part of it. It also works in reverse. Okay, let's see, Marcos, if I knew that this was 90 degrees, what would this be? They're not the same. The relationship is 2 to 1. The intercepted arc is always double the inscribed angle. So if the intercepted arc is 90, what is the inscribed angle? No. We're working the other way now. All right, so let's go back. All right, Katie, we said if this is 30, then this out here was what? 60. So if this is 60, then what is this going to be? 30, right? Didn't change. We didn't have to do different math. The numbers stayed there. So if I know what the intercepted arc is, what do I do to find the inscribed angle? Divide it by 2. If I know what the inscribed angle is, I'm looking for the intercepted arc, I multiply it by 2. Okay, all right, let's go back. All right, Marcos, if this is 90, then what is this? 45. Okay, good. All right, let's keep going. Listen, hey, I don't care. If I've got to make you feel dumb in order for all of us to understand how simple this is, that's exactly what I'm going to do. Okay? All right. Let's see, Maddie. If this is, let's say that this is 4x degrees, then what is this up here? This is a tough one. All right. Just keep it really simple. Let's go back to Katie's question. If this was 30, what was this? 60, right? What did I do to 30 to get 60? No, I didn't add. I multiplied by 2. Okay? All right. So if this was 4x degrees, what is the intercepted arc? I'm just going to do the same math. 8x degrees. All right, are we following here? Right, we're on the right track. Okay. Let's see. Let's see, Jordan. If this was 12x degrees, then what is the inscribed angle? Six x degrees. What did you do to get that? What did you do to 12x to get 6x? You cut it in half. You divided by 2. Okay. All right. This is still taking us too long to multiply by 2 and divide by 2, right? Okay, don't do that because I'm recording it and it's not going to sound like you're messing with me. It's going to sound like you don't understand it. Yeah, I understand. All right. Let's say we've got, let's say this is 33 degrees. Jose, what is my inscribed angle? Oh, 16.5. Good, because it's not always going to come out to nice, neat, all right, even degrees. All right. Do we get this? You got it? Chandler, you got it? Do I need to come up with examples for you to work out? Okay. Chandler's got to go. All right. Somebody give me a number. 890. No, we can't have 890. 15 degrees? All right. 15 degrees. Okay. How am I going to find my inscribed angle? All right. What's 15 divided by 2? Probably 7.5 degrees. Okay. Do we get this? All right, I'll keep repeating it over and over because this isn't hard, but people will still lose their brains, right, doing this, all right? Because, and the reason that I make a big deal out of this is because on our test, right, when we had a central angle, people tried to do all kinds of crazy things in order to find the intercepted arc, right? All right, how many of you missed maybe the simplest question on any test I've ever given by trying to subtract from 360 or add 360 to find an intercepted arc of a central angle when it's the exact same degree? So if we can't do central angles, we for sure can't do inscribed angles. Okay? So that's why I'm going to hammer this, right? And I'm not going to just assume that, oh, it's easy to multiply by 2, divide by 2. Okay? All right. If an inscribed angle intercepts a semicircle, then it's a right angle. Okay, here's the reason why. Because if I look at this, what does a diameter do? Cuts the circle in half. What's half of a circle in degrees? Okay, so what we're saying then is that this is 180 degrees. So what does the inscribed angle always have to be if it intercepts a semicircle or half of a circle? It's always got to be 90 because 180 divided by 2 is 90. And a semicircle is always 180 degrees. So if an inscribed angle intercepts a diameter is always going to cut a circle in half, correct? So it's always going to cut it into 180 degrees. 180 divided by 2 is always 90. All right, you can work it back in reverse. If I know that my inscribed angle is 90 degrees, what does it automatically intercept? 180 degrees, which is a semicircle. Okay, so it works back and forth both ways. Do we get this? All right, cool. Okay, and listen up. If two inscribed angles intercept the same arc, then they are the same degree. They are congruent to each other. Do you see how ACB intercepts arc AB, and inscribed angle ADB also intercepts arc AB, right? So if we knew that arc AB was, let's say, 68 degrees, then what is angle 1? What is angle 1? So we still don't get it. It's what? Guys, the intercepted arc is 68. What do I do to find the inscribed angle? Divide by 2. What is 68 divided by 2? 34. Okay. Then what is angle 2? What is angle 2? 34 degrees, because they intercept the same arc, correct? It's not a corresponding angles question, okay? It's a matter of if they intercept the same arc, then they are half of the same number, correct? I'm dividing the same number by 2, so I'm going to get the same thing in both places. So if two inscribed angles intercept the same arc, they are congruent. So angle 1 is equal to angle 2. So I don't have to solve it twice if I see that they intercept the same arc. Are we making this harder than it has to be? Hey, Jordan, you can go sit outside. Okay, I don't need, all right, I don't need the smart aleck remarks. All right, finally, if a quadrilateral is inscribed in a circle, then it has supplementary opposite sides. What does the term supplementary mean? No, means two what add up to 180? Two angles that add up to 180 degrees. Okay, opposite angle. So what two angles, give me two angles in here that are opposites. Jose, two angles in that quadrilateral that are opposites. And then O, what else? P and N. So I know that angle P plus angle N is 180. I know that angle M plus angle O is 180 degrees. Simple enough? All right. If I know that, I can solve a bunch of other questions. All right, so that's it for that. Let's go ahead and look at lesson 48, which is indirect proofs. Indirect proofs. Okay, so we're going to talk about direct reasoning versus indirect reasoning. Okay, direct reasoning is the process of reasoning that begins with a true hypothesis and builds a logical argument to show that a conclusion is true. We've done that. Okay. In some cases, it's really not possible to prove something directly, so we use an indirect proof. Basically, what we're trying to do is we're trying to prove that something is false. If we can't prove that it's false, then it must be what? And it must be true. Okay? So an indirect proof must be used if we can't use a direct proof. An indirect proof is a proof in which the statement to be proved is assumed to be false and a contradiction is shown. This is also called proof by contradiction. So these are the steps to prove something indirectly. One, we assume that the conclusion that's made is false. Hopefully we're looking at stuff that we should be looking at. Okay. Next, we show that the assumption you made is contradicted by a theorem, a postulate, a definition, or the given information. 3, we state that the assumption must be false, so the conclusion must be true. Okay, we'll look at some of these here in a little bit. Okay, in an indirect proof, it's often helpful to draw a diagram so that we can see these types of things. One of, like, an indirect proof may be something like, if we're talking about a point not on a line, you know, we've talked about points not on the line. One of the things that we looked at is that the shortest distance between a line and a point not on that line is a perpendicular line that connects them, right? So if I wanted to prove that indirectly, I might try to create other lines and look at their distances and then show that perpendicular line and see that that distance is actually shorter than all of the other distances. Another one might be, let's see, through any line and a point not on that line, there's exactly one line through that point that's parallel to that line. Okay? And by that, I might show a bunch of other lines that go through that point and see that there's only one that's parallel to that other line, or perpendicular to that other line, or a bunch of other different types of things. So there's where I would draw a diagram in order to illustrate that this one thing is true because any of the other possibilities are not true. Okay? All right, so a diagram is helpful to determine what assumptions should be made to prove the statement and in finding the postulate, theorem, or definition that contains the assumption. Okay, all right, so we've got all that. Let's look at some questions. All right, let's look at question number 1 here. Now, this goes back to our first stuff. What, we're looking at angle C. We want to solve for x. What does 2x plus 5 equal? Does anybody know? 2x plus 5, what does that equal? Okay, I got somebody who says 180. 90? How do you know it equals 90, Jose? Because it looks like a right angle. No? No? You're not wrong about it equaling 90, but your reasoning is wrong. It intercepts you just said it. It intercepts a semicircle. Notice that AB is a what? Is a diameter. Diameter creates a semicircle. So a semicircle is always equal to how many degrees? 180. So my intercepted arc has to be half of 180. So my intercepted arc has to, or my inscribed angle has to equal what then? 90. So now what do I do in order to solve for x? Well, duh. Solve it. Yeah, I get that. I want you to tell me what to do. Subtract 5 from where? Just from here? From both sides. All right, so so that will cause those to cancel out. 2x equals 85 divided by 2, 42.5. Okay. All right, and I could throw that back in to double check. 2 times 42.5 plus 5 should equal 90. Okay. All right, let's look at another one. All right, this one's a little bit more complicated, and because it's a little bit more complicated, I would say that chances are you'll see this on a test. Okay, I want to see what you guys can come up with here. All right, we want to find measure DOC. So I'm going to go ahead and show this to you. DOC. We want to know what that angle is right there. How do we do this? There is a way, but it may take a few steps. Take a chance to look at it. How can I find measure angle DOC? You got an answer? What's your answer? 145 degrees, Michael says. Do you know how you got it? All right, so you're taking 30 divided by 2 in order to find what angle? What angle? Your inscribed angle, but what inscribed angle? Angle B. Okay, so you found angle B because it intercepts this arc right here, correct? Okay, so what did you get when you got 15 degrees? Then what did you do? All right, so you took 20 and 15. Why are we doing that? What other angle? Okay, but angle O is representing 4 different angles. Be more specific. Angle AOB, good. So you're wanting to find this angle right here, and you know that there's 180 degrees in a triangle. So what's 20 plus 15? 35 degrees. Okay, so you're going to subtract what you know or from the total. So we're going to take 180 minus 35. What's that give you? 145. So, but, I mean, that's 145 here, but that's angle AOB is 145. We wanted angle DOC. How do you know that they're the same thing? No, not corresponding. You're not wrong, but I want to know why. What is true of angle AOB and angle DOC? What are they to each other? Does anybody in here know? No, not inscribed angles. They're vertical angles. Vertical angles are what? And I've told you again and again, we have to know that, right? You need to put it on a note card, put it in your back pocket, and read it every day because it's one of the easiest things to find in a proof, but most of you can't use it because you don't know it, right? You can't use what you don't know. Vertical angles are congruent. These two angles are vertical. Congruent means the same, so angle DOC is 145 degrees. Is this the only way to find 145 degrees here? No. All right, let's look at some other possibilities. Right, you're right, it is 145 degrees. And now that we know it's 145 degrees, let's see what else we could figure out. Okay? Could we figure out what that arc is? What is it? 40 degrees. How did you get 40 degrees here? 20 times 2 because inscribed angle BAC intercepts that arc, correct? If I take 20 times 2, I get 40. Okay? All right, what else could we do? Let's see. If this is 15 degrees, okay, what about angle BDC then? Is 20 degrees because it intercepts the same arc, correct? All right, so this is 20 degrees. What do we know about angle ACD? What is it? 15 degrees because it intercepts arc of 30. Now could I do the same math and take 20 plus 15 and subtract from 180 and get the 145 that way? Absolutely. Okay? So that there is more than one way to get that. Well, what do you say? AOB? AOD. Oh, you're looking for this right here? Actually, what you would do, and this gets into something that we haven't covered yet, but because you're looking at this point right here, in order to find that, we would take 30 plus 40 because of these two intercepted arcs. We'd take 30 plus 40 and divide by 2, right? So 70 divided by 2 is 35. So each of those angles equals 35. The other way to do it is if we know that we have 145 and 145, and these two angles are vertical, they have to be equal to each other. So we take 145 plus 145, right? That's going to give you what, 290, right? All the way around is 360, so we could take 360 minus 290 and take that number, divide by 2. 70 divided by 2 is 35. So either way, one of them is maybe a little bit harder than the other, but yeah, we've done that in Algebra 3, right? We will do that in here as well, but that's kind of a step beyond where we are. All right, let's see. We haven't really looked at anything in terms of a quadrilateral yet. It says find a measure of angles ACDB, so it wants to know what everything is all the way around. What do we know about opposite angles of a quadrilateral inscribed in a circle? This is one that I think Jose worked with. Opposite angles of a quadrilateral are what? It's in your notes. Supplementary. All right, what angles here are opposite? All right, but I don't know what B is. Do I know what A and D are? All right, we know that they're supplementary, which means what am I going to do with those two angle measures? Add them and set them equal to what? All right, so I'm going to take 2x plus 3 plus 3x plus 7 and set it equal to 180. What's that going to solve for? It's going to solve for x, right. All right, what do I have to do to solve for x here? Okay, so combine like terms and then subtract from 180. So 3 plus 7 is 10, so I'm going to subtract 10 from both sides. Is that right? All right, so that gives me 2x plus 3x equals 170. Okay, so 5x equals 170. Now what? Divide by 5. X equals 34 degrees. Am I done? No, what do I actually have to do? Find D. It actually wants to know what every one of these angle measures are. So what do I have to do with X? Plug it in where? To everywhere. All right. So what's 2 times 34? Kind of like 68. 68 plus 3. So 71 degrees. What's 3 times 34? Plus 7. 109. Of course, I see that 109 plus 71 is 180. What's 4 times 34? 136 minus 10. Okay, but notice that it also wanted to know what angle B was. How can I find out what angle B is? Subtract 180. So 180 minus 126, because I know that those opposite angles are supplementary. 54 degrees right there. You'll probably see a question like that on the test, but you've got to show me the work. Okay? Okay. All right, here's an indirect proof. This will be the last one we cover before I let you guys get into your homework. It says for line M and a point not on line P, or sorry, for line M and a point not on the line, which is point P, there's exactly one line through P that's perpendicular. We want to prove this statement indirectly. Assume that there is not exactly one line through P perpendicular to M. Show the two cases that need to be explored to find a contradiction. So there are two cases that would be contradictory. Okay, the statement is that there's exactly one line. So I have to look for two cases. All right. So it says one line. So what are the two scenarios that I'm looking at trying to prove that are contradictory to one line? Anything that's not what? How many lines are not one line? 2? Or anything more than 1? Or how about 0? So what I need to prove is that there are either 0 lines that are perpendicular from point P to line M, or I need to prove that there are more than 1 lines through point P that are parallel to line M. So that's what they're looking for down here. There's no line through P that's perpendicular, or there's well, that doesn't work. There's at least one. All right. So C doesn't work. It has the second part. There are 2 or more. So D, there is no line through P, or there's 2 or more lines. That's what we mean by contradictions. Okay? There can't be. But that's why it's that's why we're proving it indirectly. 1, there's not 0 because there's 1, but there's not more than 1. So that's why the statement is true. Because I can't get either side of the statement false. That makes sense? And is it confusing? Are we lost there? Okay. So in order to prove it true, I have to assume that it's wrong, right? Okay? If it's wrong, then there are 2 possibilities. Either there is 0 or there's more than 1. right? Any more than 1 is going to start with 2, right? But I can't do 2, right? I can't make a second one. But if I've made 1, I've already proven that there's not 0, right? So indirectly, I've proven that there is 1 and that there is only 1. Okay, but I have to find the 2 contradictory statements first and prove that those 2 contradictions are false. Therefore, the original statement is true. Does that make sense? Okay. All right. We do have probably not enough time. I was going to say we could look at some of your homework questions, but it doesn't look like there's enough time. All right. Do we feel like we understand this well enough? Kobe, I didn't really pick on you too much today. Just trying to get you involved. Do you remember a lot of this or understand most of what we're going through? Okay, great. So if you get me lesson 46 tomorrow, and then I think, now be careful with this, guys, because what are your question numbers from in this? 38? 48. Do you do any questions from 47? So I would write, for those of you that have a tendency to do just the next lesson and end up doing the wrong lesson, man, I'd put it in big bold print at the top of my page, lesson 48. Lesson 48. Okay, all right, we're going to stop it right there.